Today we're going to continue solving trig functions. We're going to start off by learning about quadrantal angles, and quadrantal angles are always using the unit circle. Quick reminder from the previous lesson, if you're using the unit circle, that means that the radius is 1. Anytime you see the unit circle, you have to assume that. So when the terminal side of an angle that is in standard position lies on one of the coordinate axes, the angle is called the quadrantal angle. A quadrantal angle is one that is in standard position and has a measure that is a multiple of 90 or pi over 2 radians. So if we look at my table here, I have 4 different quadrantal angles. And these angles are all given to you in positive values. However, remember that you can have negative angles. They do exist and they will correspond with these values that I gave you. They will just work in the opposite direction. So my note right there just says that these are all positive. Negatives exist and they will correspond with these angles. If we start in the box all the way to the left, we're looking at 0 degrees. 0 degrees is also 360 degrees if you were to make one full rotation around the coordinate plane. And 0 degrees is 0 radians. However, if you were to use 360 degrees, 360 degrees is 2 pi radians. If you were to reference the negative angle, like I mentioned, you would have 0 degrees, or you would have 360 degrees. Oh, I meant to say negative on both those. Negative 0 degrees, negative 360 degrees, or you would have negative 0 pi, or negative 2 pi. So those are your options for negative values in this angle location. So we're talking about the angle being right there. If you have a angle in standard position graphed on the initial side and the terminal side is at 90 degrees, this would be a 90-degree quadrantal angle. This happens at the point 0, 1. Remember that the radius is 1, so when we say 0, 1, that's telling you the length of this side is 1. 90 degrees is comparable to pi over 2 radians. And if you were to graph this angle in the negative direction, say you were to graph this angle going in this way, you would say that it's either negative 270 degrees or negative 3 pi over 2 in radians. That's if you work in the negative direction. For the next point, we're looking at initial side at 0, terminal side at 180 degrees. 180 degrees is comparable to pi radians. This point is located at negative 1, 0, and that's because the length of this part here is 1 unit. Of course, 1 unit in the negative direction on the y-axis. Sorry, the x-axis is at negative 1. If you were to graph the same angle in the negative direction, in this case you would be at negative 180 or negative pi. And lastly, if you graph initial side at the positive x-axis, terminal side on the negative y-axis, you're looking at a 270-degree angle with a point, a point located at 0, negative 1. This is comparable to 3 pi over 2 radians. And if we were to write this as a negative, so meaning if we start here and go to this point, we're at negative 90 degrees or negative pi over 2. So you can find the values of the trig functions of a quadrantal angle by choosing a point on the terminal side of the angle and evaluating the function at that point. Any point can be chosen. However, to simplify calculations, pick a point which r equals 1, and that's the points I highlighted on these. So I'm talking about this point. I know I didn't mention it much before, but we're talking about this point. So if you choose that point, then the r value is 1. It's the point where your angle intersects what we call the unit circle. All right, I know I talked about this in the last lesson, but I'll just remind you. If you're writing an angle and you don't know the angle measure, you can use the symbol, it's called theta. And it represents an angle. Kind of like a variable that we use when we're solving. So it might represent a number, such as x. X might represent a number. When we're dealing with angles, we tend to use the Greek symbol for theta. Okay, number 1 says evaluate trig functions of quadrantal angles. At each indicated angle, find the exact value of the 6 trig functions, if defined. If not defined, write undefined. So we're talking about the 6 trig functions that we learned about last lesson. So you want to identify the point where the terminal side of the angle intersects the unit circle. And we're going to use the chart above to identify this.